Okay, so let's just start with a question. Does sine negative theta plus sine of theta equal 0 for any value of theta? So this is a true or false. If I pull these up over here, first of all, we're going to use our even odd identities down here. So sine negative theta, that's sine negative x, is equal to negative sine of x. So basically, this first term is equivalent to negative sine theta, according to that identity right there. And plus sine of theta, that's just sine of theta itself. So what happens if you have a negative 1 plus a positive 1 of the same term? What do you get? Yeah, equals 0. So what would we say about this? True. Okay, another type of problem we'll see is rewrite over a common denominator. So specifically, they give us instructions on this one. And if I have a common denominator on this, so first of all, the common denominator for that would be 1 minus sine of u times 1 plus the sine of u. Okay, now for this term, 1 minus sine of u, what's the missing part? 1 plus sine of u, right? So 1 plus sine of u plus. Now over here I have a 1. It's already over 1 plus sine of u, so that's already over this. What's the missing part? 1 minus sine of u. So that's going to be 1 minus sine of u. Alright, so now we can add like terms. So what's 1 plus 1? This isn't, now this is a plus sign in between, so we're not foiling out here. This is a plus, so just 1 plus 1 would give us 2. Now, positive sine of u minus a sine of u just cancels those terms out. It's like adding like terms. Okay, but in the denominator, this is multiplication. So let's go ahead and take a minute and FOIL this. So 1 times 1 is 1 plus sine of u. Then negative sine of u times 1 is negative sine of u. And then we have a negative sine of u times sine of u, which is going to be negative sine squared of u. So I bring down my 2. This sign minus this sign cancels, so I have 1 minus sine squared of u. Okay, do you recognize this? 1 minus sine squared u, which would be one of our Pythagorean identities, which is going to be what? Good, cosine squared u. So 2 over cosine squared u. Now, that's the same thing as like, what would be 1 over the cosine squared? It's the reciprocal. What's the reciprocal function of over the cosine? Secant squared. So I just bring down the 2, which is in the numerator, and then I have secant squared u using the reciprocal identity. So that's like, let me just, 2 times 1 over cosine squared u, right? So this is the part that I rewrote as secant squared u. Okay, and so I just labeled the identities that we used in those locations. Okay, the next example tells us to simplify this term by factoring. So we're going to, first of all, let's just rewrite this. So I have 1 minus cosine squared v. Let me rewrite it so I have room to work. Cosine of v, sine of v. Okay, this is 1 minus cosine squared, and we're trying to factor. So this is actually a difference of perfect squares. So this factors out to be, if you remember difference of perfect squares, it's going to be 1 plus cosine of v times 1 minus cosine of v, right? So you remember doing that from algebra. And then in the denominator, what about both of these terms? They both have what in them? A sine of v, so let's take out a GCF. The reason why we're doing that, the reason why I didn't go straight to a Pythagorean identity right there is because specifically they told me work on factoring. Okay, so now I have GCF is sine of v. So if I divide this term by sine of v, I have 1 as a placeholder. And if I divide a sine of v out of this, factor out a sine of v, then I'll have cosine of v. Now what happens here? 1 plus cosine of v, 1 plus cosine of v, those terms simplify, and we would be left with 1 minus cosine of v in the numerator over sine of v in the denominator. Now, we can, I'll make a note over here, separate into two terms. And let me pick a different color. So I'll have, that's 1 over sine of v minus, and then the other one would be cosine of v over the sine of v. Now using our reciprocal identities, what's the reciprocal of 1 over the sine? Cosecant of v, good, so that's using reciprocal identities here. And what's cosine of v over sine of v? Cotangent of v. And so this is as simplified as we can go. Alright, number 6, we're going to multiply sine theta cosine theta over 1 minus cosine theta plus sine of theta times cosine theta plus sine of theta. So it wants us to multiply out. Okay, in that numerator, there's not much simplifying I can do here. So first of all, I'm just going to bring that down, sine of theta cosine of theta. It looks like our denominator is going to be what's really going to take some work. 1 minus. Now we're going to get over here, and this is a binomial times a binomial, so we're going to FOIL it out. So cosine of theta times cosine of theta will be cosine squared theta. Okay, my next one is going to be cosine of theta times sine of theta, which would just be cosine theta sine of theta. Alright, and then coming back now, I'll have sine of theta times cosine of theta. It's just, I'm just going to rearrange the order, so cosine of theta, sine of theta. It's commutative, so it doesn't matter since it's multiplication. It doesn't matter which one I put first. And then this one is sine of theta times sine of theta, which is sine squared theta. Now let me extend my bar. I'm actually going to try to move this in the center a little bit better. Sine theta, cosine theta. Okay, now let's clean up the denominator a little bit. What about, let's see some things we can notice. Sine squared theta and cosine squared theta. Make sure this is in parentheses. Make sure the entire thing's in parentheses. And let me get my highlighter back. Okay, so cosine squared theta plus sine squared theta is just going to be what? Just to pull that up right quick, sine squared theta plus cosine squared theta is equal to 1. So that highlighted portion we're going to simplify to 1. Let me move that out the way now. So if I'm just going to work with the denominator, so I'll have 1 minus, that's going to be 1. So the highlighted part's going to be 1. Now I have a cosine theta sine squared theta term, and I want to add it to a cosine sine. So these two are like terms. And so if I have one like term plus another like term, how many do I have? Two of those terms. Two of cosine theta, sine of theta. Good. Now, let's just bring our numerator down. We're just going to keep bringing it down until we get to the point we're ready to work with it. Okay. Out. All right, so in our denominator, we're going to distribute this negative out, so you're just going to have 1 minus 1, so that's a negative 1, and then you have minus 2 cosine theta, sine of theta. Okay. Now what happens to 1 minus 1? These two terms go away, and then what about our sine of theta, cosine of theta, cosine of theta? They simplify, so we're just going to be left with 1 in the numerator as a placeholder. This 1 minus 1 simplifies, so we just have a 2 in the bottom, so a negative right there. Okay, so then that's just going to simplify because the 1 minus the 1's gone. The sine theta, cosine theta is reduced with these, and we'll just have that left.